Hey, welcome back to our Facebook LeetCode interview series here on the Web3 8. We're going to be tackling the top most frequent interview questions at Facebook according to LeetCode in the past 6 months. Today we're tackling number 560, subarray sum equals k. This is a very fun question. It's very annoying, but once you learn the trick, it is very easy to understand. So let's go ahead and read through it. Given an array of integers and nums and an integer k, return the total number of subarrays whose sum is equal to k. So we are looking for a subarray of values that is equal to this k. And we're trying to get the count of those. So a subarray is a contiguous, non-empty sequence of elements within an array. All right. So here we go. We have our input of nums 1 1 1 1. We have k equals 2 because this subarray right here, these first two is equal to 2, and these second two are equal to 2. All right, very good. And then we are looking again at our input here where our target is 3. So we have a subarray of 1 and 2, which is equal to 3, and we have a subarray of 3, which is equal to 3. Now, this question would not be that difficult if we are given numbers that are sorted. But it does not make that assertion. So we must assume that these numbers cannot be sorted. So that's what makes this problem a little bit difficult. So the trick of it is to keep a running count, but we also need to keep a count of how many subarrays prior to that have certain values. So for example, we have a running sum of 3 here, but we know that there is a subarray in front with a value of 1. So 3 minus 1, that would be 2. So we have this one here, we hit 2. And then this one here, we have 3, but we know that we have a count of 1, 1. So that would be our plus 1. So it will make a little more sense as soon as I code this up for you. So first up, what we're going to do is create our map. We're going to keep a map of these, I guess, so-called prefix numbers. So these are numbers that are potentially values that we can remove, and it'll make a little bit more sense. So let's go ahead and call it prefix sums. All right. And over there, we're going to be creating a new map. And inside this map, we are creating our initial value, which would be 0, because the beginning out of bounds has a value of 0, and there is one instance of that 0. Next up, what we're going to be doing is keeping our running sum. So let our sum, and we're going to be starting at 0. And then we also want to keep track of the number of subarrays that have a value of k. So we'll say let our result equal 0 as well. So let me go ahead and pull up a special, maybe not special, but an interesting test case that I can show you. So let's say we're given the values of 3, 2, 5, 1, 1, and 7. All right, so our k that I want to hit will be a, say, let me add one more. Let me add a 3 here. Let's say our k is this 5. Okay. So what we're going to do is have our sum is going to be starting out at 0, and then we have our prefix sums. So of course 0 will have a count of 1 initially. So we're at 0, and then we move ahead here. We have our sum is now 3. So we'll update that to 3. And then we say, all right, if 3 minus k, so we are looking for, we're looking for k minus 3. No, sorry. We're looking for 3 minus k, which would be negative 2. Yeah. So if our current sum is 3, We have a -2. -2 does not appear up here, so we're just going to go ahead and add our 3, which now has a value of 1 instance of 3. Next up, we hit a 5. Very good, very good. So now our sum is 5. So we do 5 minus k. That would be 0. So we look up how many instances of 0. And we have this 1 instance here. So that would be just our standard array. And then that's when we update our result. So will now equal 1. And then we can update this 5 to have a appearance of 1. Next up, we have this here. Our new sum would be 10 because 3 plus 2 plus 5 is 10. And then we say this sum minus k is 5. So we need to look for a value of 5 before it to remove in order to have this value of k. And what do you know? We do have a 5 right here. So we have a 5 has a instance of 1. So then our result increases to 2. Next up, we hit this 1 here. It is now 11. So 11 minus 5 would be 6. So then we look through our map. We are looking for any prefix that has a value of 6 that we can remove from it. And we do not have a prefix of 6. So what we're going to do is increase this by 1. All right, and then what we're going to do is go ahead and add our second one. So now we're at 12. 12 minus 5 is 7. Again, we look through here. Are there any sums of 7 that we can remove? There are not. So we're going to go ahead and increase this. This should not be a 5. No, that should be a 5. This should be a 10 is 1. And we also have an 11. Sorry. Bit confusing. So now we have a prefix of 12 that we can remove from future. Right? Yeah. And then next up, we hit this 3. So now our sum is 15. Right? So then we take a look. We do 15 minus 5 is 10. There is one instance of 10, which would be these values here, represented here. So we can remove those. And guess what? There's one instance of 10, so we increase our result by 1, and we get 3. And that would be our answer. So, yeah. We're going to go ahead and just build out that logic. So, for our constant num of nums, so we're going to iterate through all of the numbers that we see. First up, we're going to say our current sum, not our current sum, we'll just say sum is now equal to an increment of num. Next, we want to check if our prefix sums has this value of current sum minus our k. So here we'll say if our prefix sums dot has, and we're going to say sum minus k, then if it has it, what we're going to do is say that our result will be incremented by the number or frequency of that value. So we'll say prefix sums dot get, and what are we getting? We are getting the value of sum minus k. So from there, what we want to do is now update the prefix map or prefix sums map with our new current sum that we could remove from future values. So we'll say let our prefix count equal our prefix sums dot get, and we're going to be getting our current sum, which would just be sum. Trying up a new naming convention. I had a talk with a mentor, said I need to switch it up a bit, or 0. So if this does not exist in our prefix sums, we need to set that value to 0 to begin with. Next up, what we want to do is set it again. So we'll say prefix sums dot set, and we are setting our current sum, which would just be sum, and our prefix count plus 1. And then at the end of all that, we are returning our result. So yeah, pretty fun stuff. Let's go ahead and run it just to show you it works. It does work. All right, so we have our 2 test cases here. Yeah, and then let's go ahead and submit it. And here we go, better than 81% of other participants. Very good. So let's go through this time and space. So anytime we're creating a map, it's usually O of n, where n is the number of numbers present in our nums array. This has a, what would that be? A space complexity of O of 1. Result has O of 1, so we have O of n, O of 1, O of 1. So this would just become O of n. And then over here, we are iterating through each num of num. So time complexity would be O of n for this for loop. O of 1, this is an O of 1 because we're going with a map. This would also be O of 1. This would be O of 1, and this would be O of 1. So worst case scenario for time complexity would be O of n, where n is the number of nums in the nums array. Yeah, so that is how you solve question number 560, subarray sum equals k. If you have any questions, post them below. If you found this video helpful, please like it, subscribe if you want, and please share it with a friend if they have an interview coming up. Thank you so much, and have a great day.